Hi, Larry Stewart here with ForConstructionPros.com at Caterpillar's Tanaja Hills demonstration and proving ground in Arizona. I want you to meet Joe Forcash, who's engineering manager with CAT Robotics. How about that? CAT's got a robotics division now. The applications that we're seeing at this CAT trial video of the compact track loader that's running completely autonomously, that's a little pre-market, right? That's not an available machine yet, but it's operating just like you would expect, huh?
Yep, this is the first time we're showcasing this. So a couple years ago, we acquired Marble Robotics in San Francisco. We've basically taken our mining truck technology that we've been working on for decades. We've taken the CAT command for remote control technology that's available in production today for construction industries. We've acquired Marble Robotics that was working on basically delivery robots in dynamic complex environments, and applied all three of those basically into the semi-autonomous compact track loader that you see today.
Yeah, it's interesting the technology progression here, because Caterpillar's been into autonomous machines for 20 years on mine sites, right? Advancement that Marble Robotics brought to you was essentially a robotic or an autonomous gear setup for a much lighter machine, maybe perhaps at a lower cost point.
What we needed to do was be able to provide the right solution for construction customers to bring that cost down, to be able to work in environments that had no network infrastructure and understand applications on how you could apply this technology there. There's a lot of building blocks for mining that we can apply, but it didn't get us all the way there. And so what the CTL does is give us an introduction into the autonomy space in construction. Now we've got the bookends from a large machine down to a small machine. And then over time, we can then fill the gaps with all the different products we have. Now that we've helped driven that cost down, created a technology that could work in a more complex dynamic environment. We've got the mining side of it, and then we can basically take that technology all the way through construction, through mining, with various products.
I would think that a lot of our readers would be particularly interested in being able to operate without a network infrastructure in place. What kind of capabilities does this system offer for that kind of situation where a contractor's working in a place where there is no connectivity?
The difference with mining is you're typically there for 50, 60, 70, 80 years at a single site. At a construction site, you come in and you're only there for maybe 6 months, a year. So you want to come in, you want to be able to be as nimble as possible to get the job done and then move on to the next. So we take the customer design files that they already have. So take an example as a solar farm site. They come into a solar farm and they're going to go build out a solar farm miles and miles. They know exactly what everything needs to be done in order to construct that site. We can ingest that file very quickly into our back office system. We can bring that onto a tablet controller that basically hosts that map. Go connect to a machine on the field. That machine, the CTL, basically has its own hotspot. You connect to it, you can share that data into it. You use remote control on the tablet controller to go ahead and pick up material with the CTL. Use that map in order to tell the machine where to go. At that point, it's completely disconnected. It will autonomously drive to that location. It will drop that material off in return. And so it allows us to be able to get to a job site very quickly and be doing autonomy very quickly by not having to leverage coming in early on, setting up a network, all the additional costs of doing that.
You're clearly building on technologies that are already in the field, controlled by wire on the compact track loader itself. It's already got computers on board. Your autonomous system, the CAT command autonomous systems that are already commercially available, allow you to operate that machine from remote control. That autonomous system on top of that, and now you've got a system that can identify obstacles, can follow a map, get to where it needs to go.
The fact that they're all built on each other, you can spend a year, multiple years working on remote control. You already understand pieces of autonomy the day one when you start using it. You understand the mode lights, that blue light means unmanned mode versus green light means manned operation. And so those building blocks, basically you learn as you use the technology over time to grow into autonomy, is also built into the building blocks of how we've kind of applied the technology over years. We also leverage some of the features in that base machine an operator has today. So take self-level, for example, on a CTL with forks. That's a piece of what an operator in a cab uses today to go pick up pallets. We're using that same feature in the autonomy layer and the sensors that we're using to do that as well in order to complete that same task autonomously.
The return to dig or return to lift is built in there so that the machine doesn't have to make that adjustment.
So we're using a current production D3 machine and we're adding technology on top of it. You don't have to buy a special built machine for autonomy. We take the current machines we have and just add the technology on top.
It's essentially a retrofit. This isn't a specialized autonomous machine. It's just A D3.
From years of building from the DNA of the machine to be capable for that, to be able to enable that retrofit today.
Yeah, and an interesting point about how ready Caterpillar was for this, that that Marble acquisition was 2 years ago.
Yes.
And now you've got a machine that you're preparing to at least show to the world, doing its thing.
Yeah, and so technology is just moving faster and faster every day.
Yeah.
So 2 years ago, we acquired Marble. Within weeks, we had a prototype system up and running. And that's only 10% of the journey it takes to get to a commercial solution. But very quickly, we were able to apply their technology right onto our machine and be able to start running. And we've been building ever since, to the point of what you see today and what we'll see over in the future as we grow this into a commercial product.
What kinds of things do you need to learn about the dynamics on a construction site before you're able to apply this to like mass excavating or a site that's not as closed as a solar farm?
Many of our customers haven't thought yet about how to bring autonomy into their job. And so one of the things we did with the CTL is we started doing field trials last year at customer sites that allowed us to learn how to integrate the autonomy system in the application, for example. And so we have a lot of development projects that we have working. And so one of the things we'll do that the general public won't see is we'll go integrate with certain customers and start building the technology right with them, so we can get that early feedback well before you see a commercial product, because it really takes understanding the application the customer's in, it takes understanding the repetitive tasks they're doing, and also make some changes from a customer perspective on how to adopt it. For example, the system has a safety system built in, right? So it expects the LiDARs and cameras, if a person gets too close to the machine, it's going to slow down or it's going to stop.
Yeah.
So on a traditional construction application today, you see people very close to the machines in operations. If you want to maximize the uptime and the productivity of an autonomous machine, you've got to have processes that keep people a little bit farther away from the machine to allow it to operate at max productivity. Or if you have people nearby it, it's going to slow down constantly or be stopping, and you're not getting the biggest benefits out of the system to take that repetitive task and be able to get it done as quickly as possible.
Yeah, and I assume too, you also have to make sure people aren't setting things down in the paths where these machines are going to run, because they're going to stop if they see an obstacle or it'll go around.
So our system's intelligent enough to know the difference between an object and a person. And we treat light vehicles, for example, as people, because a person can be in those vehicles as well. Yeah. So if we were driving autonomously down a path and there's a cone, for example, in the middle, we can, if there is a path around it, we will dynamically find that path and drive around it. We will get relatively close to that cone as we do that driving. If there's a person in the path, we will slow down and stop. If there's a large enough area, we can potentially take a very wide turn to get around there. We understand the environment and we treat it differently into how the machine's going to behave with those different types of objects. And so if you drop something on the ground, we can detect that and we can understand how to get around it. Mm-hmm. That's different than if a person is laying on the ground, how we would treat that same person.
Is this gonna push the human resources on construction sites toward more skilled operations?
So by us being able to reduce 4 operators to 1 to be able to take the CTL and go complete that task, you can definitely take that labor and put them on more skilled activities basically at the job site. And so where I really see us fitting in is we fill the gaps of labor where those labor shortages are in applications like solar farms and others.
Yeah. The guy with the command controller, does he have a different skill set in order to kind of keep that whole operation running?
Yes. So he'll need a certain level of training in order, just like on our command stations today or our MineStar applications today, there's a certain amount of training and skill set you'll need in order to run that. And so that operator is going to be a bit more skilled. If you look at remote control, I'll take as an example with stevedore applications. The most important person on the job site is the crane operator, because he's always moving material and he's keeping your productivity of a stevedore application up and running. Your operators that are supporting that from a remote control phase on the wheel loaders and excavators are significantly less efficient because they're just trying to provide material to that operator. By taking those operators, putting them into a command station and allowing them to run at full utilization across multiple products, they've now become more skilled and more valuable to the company, in the fact that now they're keeping operations basically moving at the same rate and same importance as the crane operator does in their traditional applications.
All right, well, thanks so much for taking the time with us, Joe, and wish you the best of luck with the tech.
Thank you.
Yeah. There's a war going on inside, just to name a couple. I battle with porn and pride and a persistent